Am I audible? Is the screen visible?
Yes.
Yes, sir.
So we were looking at the probability distribution in the previous lecture. Uh, the probability distribution, we first of all started with the random variable. So, what is a random variable? Random variable is a function from the sample space to the real number. So, what it is going to do is it will assign a real number to each and every point of the sample space. And if the range set of the sample space is finite or it is countably infinite, then it is called the discrete random variable. If the range set is an interval or some union of the intervals, then we will see that it is a continuous random variable. So if we have a discrete random variable, then we have the probability mass function. So given probability mass, for each and every sample point, we have a table in which for each random variable or each point in the range set of the sample space, we have some probability assigned to it. We'll call it a probability mass function if and only if all the values are greater than 0 and the summation is equal to 1. If these two properties are satisfied, then I will say that it is a probability mass function. Then the probability distribution is actually a function which is from the range set of the random variable to the real numbers or the interval 0 to 1 in such a manner that each of them it is greater than 0, summation is 1. So then we'll say that it is a probability mass function. So then we started with an example. We have found out a complete probability distribution for a given experiment on the sample space. Then the next example, uh, in order to have this distribution be a probability distribution, we found out the value of k and also found out the probabilities for different values of x. Fine. So in today's lecture, we'll solve one or two more examples and then we will look at what happens in the probability when you have a continuous random variable. So example, the following okay, verify whether the following functions can be regarded as can be regarded as probability mass function abbreviated as PMF for the given values of x. First, x p of x 1, 2, 3, 4, then 0.2, 0.4, 0.3, 0.5. So is it a PMF? Is it a
No.
PMF? No. Why no?
So
So
summation more than
because
one.
summation is more than one.
Yeah. So in this case, of course, each of the pi is greater than 0, but summation of pi's, which is equal to, in this case, that will be 1.4, not equal to 1. So is not a PMF. Second, x, p of x minus 1, 2, 3, 4, 0.5 minus 0.3, 0.3, 0.5. Obvious. Apurva.
Yes, sir.
Yes, is it PMF? The second one?
Yes, sir.
Yes. Okay. Akanksha,
Yes, sir.
is it PMF? The second one?
So I wasn't present in class yesterday and I haven't seen your recorded lecture yet.
Okay.
Sorry for
Okay.
that.
So can I?
Yes, please.
Sir, it is not, since um, p of I must be greater than 0, greater than equal to 0.
So for P of x equal to 2, the probability that we have got is minus 0.3. Which is not possible. Probability cannot be negative. Okay. So this is less than 0. So not a probability mass function. What about the third one?
Yes, sir, it can be, I guess.
Yes, I. Yes, sir.
Okay. 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 So what the third one says that, so at P of x equal to 1, that will be simply 1 by 14. Probability of x equal to 2, that will be 4 upon 14. And probability of x equal to 3, which is 9 divided by 14. And otherwise it is 0. The probability of summation probability of x equal to I is running from 1 to 3. This will be equal to 1 plus 4 plus 9 divided by 14, which is 1. And of course, each of them is greater than 0, as you can see. Hence, it is a PMF, probability mass function. Fourth one, P of x is equal to x minus 1 upon 2 if x is equal to 0, 1 and 2. That is
So,
equal to 0.
Sir,
Otherwise,
it's not.
why?
Sir, 0 minus 1 is minus 1 by 2, which can't be
Yes,
possible.
yes, yes. So probability of x equal to 0 is probability of x equal to 0 is less than 0. So not a PMF. De- determine C such that the following, such that the following function is a PMF. C into 5 x is equal to 0, 1, 2, 3, 4, 5. What is the notation?
Sir, is this combination?
Yes, the main reason I have took this example is this is the notation when someone writes 5x. This means that 5
5C0. Sorry,
cx.
5CX.
Yes.
So, sir, it is not possible for every value of x.
Why
It
not?
is, sir, because for 5C1 it is 5, 5C2 it is 10, 5C3 it is 10, and 5C4 it is 5, and
We need
5C5 it is 1.
still you will get some answer for the value of c.
So for 0 and 5 we'll get 1.
No, no, not like that. It's not like that. Okay, anyways. So
Sir,
P is
will
of
it
course
be
greater.
5C1 into C plus 5C2 into C summation up to 5
Mm,
equal to 1?
yes, yes, exactly. But what is the value of C then?
Sir, I'm
For
calculating.
We will
1 by
calculate
31,
it.
sir.
yes, please
Okay,
calculate
sir.
it.
Sir, I got it. So 1 by 5 for the first one.
1 by
Sorry,
31, sir.
1 by 0. So which is not defined.
Wait, Hasnan, wait. You'll get it. P is of course greater than 0, the first condition, and the other one summation P has to be equal to 1. Summation Pi, in this case, I is running from 0 to 5. So what we will have is C in bracket 5C0 plus 5C1 plus 5C2 plus 5C3 plus 5C4 plus 5C5. This has to be equal to 1. Note that this can be directly found using your calc. Make use of your calculator wisely. You will get the answer for this in just some seconds. Look at the summation that you have in your calci.
So that is coming out to be 1 by 32.
Yes.
C.
Yes, sir. 1 upon 32.
Try this on your calculator because in further studies I'm going to need this.
Yes, sir.
So you,
I did it on calculator only.
yeah. Mm, and everyone else who didn't try it on calculator, please do it. There is summation and also there is 5cx. Okay. When you press the combination button, it will show you this kind of structure will be there. Two brackets. You can just use the arrow buttons. You place here an alpha x, and here you can put 5. Then give the limits for I is running from 0. Sorry, not I, x. X is running from 0 to 5. And I guess you will get 32 in that case. So C into 2 raised to 5 is equal to 1, which gives me C is equal to 1 by 32. Next point is the cumulative distribution function. Which is also called as, first of all, it is abbreviated as CDF, or it is called the distribution function. Before I write down the definition, I need you to recall what was cumulative frequency distribution. What was cumulative distribution function? No, sorry, cumulative frequency distribution. No one?
Sir, cumulative frequency, it was the observations that depending upon whether it is less than or more than.
Okay, if it is less than,
We just added, means from top
hmm,
to bottom, and if it is more than cumulative
you,
frequency,
no, you're right. But what was the definition? Why do you add?
So it is the number of observations less than or equal to upper limit of the corresponding class.
Exactly, very good. So, in the similar manner, when we say cumulative distribution function, what it does is calculates the probability of all the values of x less than the given number. So, I'll write down the definition later. Just let me tell you that the cumulative frequency distribution is denoted by capital F of x. What does it mean? It means the probability of all the x, say capital X, less than or equal to given this x. Say, for an example, if I want to find capital F of say 5, what I will do is I will calculate the probabilities of all x less than or equal to 5. Just like the cumulative frequency there. In that, we were calculating all the observations below the upper limit. In this case, what I'm doing is I'm calculating all the probabilities of all the numbers less than the given number. Fine. Let's write down the definition. Let X be a discrete random variable. Taking the values x1, x2, dot dot dot, xi, dot dot till xn with the probabilities p1, p2, pi, dot dot to pn respectively. Then the cumulative distribution function, then cumulative distribution function abbreviated as CDF, or which is also called which is also called the distribution function. DF is denoted by capital F of X and is defined as and is defined as capital F of X is equal to probabilities of all X less than or equal to this small x. So what I'm going to do is I will sum up the probabilities of all the X which are less than this given X, which can also be written as summation Pj, j is running from 1 to I. Look here, what I'm x less than or equal to xi is there. So xi is the largest. So what I will do is I'll take only this pj's up to pi, not beyond that. That's probable distribution function of f of xi. This will be a better notation. An example. Consider the following probability distribution of a discrete random variable, of a discrete random variable. X. First one, obtain the CDF. Obtain CDF, which is cumulative distribution function. And second one, draw the graph of CDF. So we have Xi's, we have Pi's as 1, 2, 3, 4, 5. That's 0.1, 0.2, 0.3, 0.2, 0.2. Finding a CDF, it means that we simply need to make a column or a row. We need to give a table where we will have f of xi. So at 1, what is f of x? Capital F of x1, which is probability of all the x less than x1. What this will be? You should be able to read the data.
0.1.
0.1. For 2,
0.3.
that will be 0.1 plus 0.2. So when I say x2, what will happen is probability of x equal to x1 plus probability of x equal to x2. So that is going to be 0.3. Third,
0.6.
0.6. So x3, again one term will be added, probability of x equal to x3. Similarly, we go ahead now. 4, that will be 0.8.
1.
The fifth is 1. Can I say that the last entry always need to be 1 in this table at least?
Yes.
Yes, sir.
So total probability is always 1. So the last entry will always be equal to 1. Now what about the graph? Look what happens in the graph. So 0.1, 0.3, 0.6, 0.8, and 1. And we have 1, 2, 3, 4, 5. In the interval 1 to 2, what will happen? So if I have probability of capital F of x equal to 3 by 2, say, what this will be? Probabilities of all the x less than 3 by 2. Am I right? What this answer is going to be?
0.1.
0.1.
Sure. You're telling me yes, 0.1 exactly. So can I say that in this interval, excluding 2, will always have 0.1? This at this point it is 0.1. 2 is excluded, so I will make this kind of circle. So 2 is excluded. Once you include 2, if you take capital F of x equal to 2, that is going to be 0.3. Again, at this place, it is 0.3, 3 excluded. Similarly, when you look at x equal to 3, what we will have is 0.6. X equal to 4, it is 0.8. And at 1, it is, at 5, it is simply 1. We'll leave it. The graph looks like this.
Sir, can you
Fine.
scroll up for a bit? Yes, done.
Next example. The following is a cumulative distribution function of a discrete random variable. Of a discrete random variable. The function is x equal to -3, -1, mute yourself. Sakshi, mute yourself. 1, 0, 1, 2, 3, 4, 5. F of x is 0.1, 0.3, 0.45, 0.65, 0.75, 0.90, 0.95, and 1. First one, find PMF of x. Okay, I'll change the question a bit. I will make this later at the end. First of all, probability of x 1 to 3, probability of x equal to 1. And third one, find PMF. And the fourth one, find probability of x equal to even. And the fifth one, probability of x equal to -3, condition x is less than 0. Sixth, probability of x less than or equal to 3, condition x greater than 0. Okay, let's leave the others because as you can see, finding out the probabilities of these things is very much easier when you have PMF. So how can we get the PMF? Anyone?
Instead of 0.1, we'll write 1 and then
Why?
minus same like cumulative frequency of less than type.
Okay. Instead of 0.1, we will write 1. No, no. Look, the formula that we have. Say, if I want to find the probability of xi, say, what's the formula? The formula is summation. The problem is once I go for this theory, you won't be able to think on your own. So still you have time. Please think, if I want to find probability of x equal to -3, what it is going to be?
Sir, 0.1.
And what about -1 then?
0.3 minus 0.1.
Yes, exactly. Probability of x equal to 0.
0.45 minus 0.3 minus 0.1. Yes.
Exactly. The same idea we will use. Okay. So if you look at the frequency distribution in the previous example, as you can see, what you did was this was your PMF. This was your PMF. And using that, we found this CDF. And what we did was we just went on adding the probability 0.1, then 0.1 plus 0.2, 0.1 plus 2 plus 3, and so on. So if I want to go from this to this, what I will have to do is I will have to go on subtracting. And the theoretical proof for this, if you wish to, then f of xi minus 1, what this is going to be j is running from 1 to I minus 1 pj. So if I have capital F of xi minus capital F of xi minus 1, so this will be summation pj's, j is running from 1 to I minus summation pj's, j is running from 1 to I minus 1. So what will happen is the probabilities up to I minus 1 will get cancelled out, and the only thing will remain in this case is going to be pi. So if I want pi, then what I have to do is I have to subtract the previous cumulative distribution from the present distribution function. So using this technique, what I will do is I will make a table of p of xi. Okay, let's. Now let's keep it as it is. It will be helpful later. So the PMF is, we have x, we have pi's, xi's. So -3, -1, 0, 1, 2, 3, 5, 8, 0.1, 0.3, 0.45, 0.65, 0.75, 0.90, 0.95, and 1. What is the first question? Next, probability of x equal to 1. This is directly from the table 0.65. The next one, probability of 0 less than x less than 2. This is going to be probability of
One.
the probability of 1. If I want to find it from the cumulative distribution function from this table, if we want to find probability of x equal to 1, what we will do is 0.65 minus the summation of all these three. So that is again
C.16.
0.16. Sure.
Yeah.
So that will be 0 less than x less than 2. 0.65, 4 and 95. Okay, that is 0.65. Then the third one, what is it? Fourth one. Find probability of x equal to even.
Could you please explain again those probabilities that you wrote right now?
I'm using this probability mass function here. This
So,
is what
how can it be the same as the CDF?
I have made it same as the CDF or what?
Yes, sir.
Oh,
That's
sorry. It's not the same. We have to subtract it. I actually explained everything and
yes.
made
I
it
was
this.
very confused. Sir.
Yes. Thank you so much. Sorry. Now what we have to do is we have to take the next one and then uh, just a minute. Yeah. So how we were calculating? You take the, if I want to find the probability of x equal to -1, what I have to do is I need to take 0.3 and subtract 0.1. Just it was in the same manner. The same. That is not working. So the probabilities are going to be 0.1. The next one will be 0.3 minus 0.1. Yeah. So 0.3 minus 0.1, this will become 0.2. The next one will be 0.45 minus 0.3 minus 0.1. That is simply 0.15.
What? Huh? 4 1 na sir.
No. 0.45
It should be
minus,
0.45 minus 0.3 only, na?
yeah. This is the complete thing, right? Up to this. So 0.45 minus 0.3, that is 0.15. Shivani, is it clear?
Oh yeah, yes.
0.15. Then for 1, at 1, 0.65 minus
Point two.
0.45, that will be 0.2. The next one will be 0.1,
0.1.
then 0.15, 0.05. The last one is also 0.05. Okay. So probability of x equal to 1, 0.2, similarly this will be also 0.2, then x equal to even, probability of x equal to 0 plus probability of x equal to 2 plus probability of x equal to 8, that is 0.3. Then let's get to this fifth one. It is a important one. X equal to minus 3, given that x is less than 0. Probability of x equal to minus 3, condition x is less than 0. Yes. I'll just recall probability of A condition B. This is equal to probability of A. What was the formula?
Intersection B upon P of B.
Upon P of B. So what will happen is this will actually be equal to probability of x equal to minus 3. So actually not the probability, the event is that x equal to minus 3 intersection x less than 0, right? Upon, so what is the intersection for both these events? X equal to minus 3 and x less than 0. What is going to be the intersection?
X equals minus 3.
Simply
X
x
equal
equal
to
to.
minus 3.
So can I write this formula directly as probability of x equal to minus 3 upon probability of b? The probability of b in this case is going to be just the square probability of x equal to minus 3 upon probability of x less than 0. X equal to minus 3, it is 0.1. Is it 0.1?
Yes, sir.
Yes, upon probability of x less than 0. So capital F of x equal x strictly less than 0. Na? So that is 0.3, right? Less than 0, 0.2 plus 0.1. So probability of, so first, second, please tell the answer. This is third, and this is fourth one, probability of x equal to -3, condition x less than 0 is equal to. It is
1/3.
which is 0 point. Can you tell me the fifth one now on your own? The fifth one was probability of x less than or equal to 3, condition x greater than 0. What is the intersection?
X equals 1, 2, and 3.
1, 2, and 3. So if you look at the intersection of this is going to be probability of 0 less than x less than or equal to 3 upon the probability of x greater than 0. Just put the values and tell the final answer.
9 by 11.
Yes?
9 by 11. It's
That is
0.45 by 0.5.
point.
45 by 0.5.
No, tell me the final answer.
9 by 11.
0 point.
8, 1.
8. Is everyone clear with this? Fine, so we'll stop here.
Sir,
Yes.
sir, in the original one,